All right. Hello, my name is Jacob Check, and I do not have a lab kit. However, I still participate in this lab, and I'm going to show you exactly how. Now, I know we need syringes, but I figured that, since I don't have that, I felt like it was necessary to give you a little demonstration of exactly how this works. So, we need our baking soda solution. We have to, put the soap and stuff in that after we dump it into some stuff. We've got to get that out, and we're gonna get, syringes. You're gonna cut up your leaf pellets and stuff. Already did that before, and then you're going to place them in here and slowly suction out some stuff. You know, you're gonna increase the suction while you're doing this, right? Now, I don't have a syringe. I do have handy dandy water bottles, right? I'm gonna show you exactly how this works now. Already, our high school physics taught us, can't have empty space. It's gonna go. So when I put the lid on, right, and extend, going to be very similar to a syringe. So now all I have to do is fill this up, right? Now I just took a Lowe's bucket and I used a lot more baking soda than called for, so I kept it in decent portions. So I didn't specify. Um, you know, you just fill that bucket up, and you make your solution there. So got a big Lowe's bucket. I finished with the experiment already. I don't have that, so I'm just going to use this good old sink, and we're going to pretend with this water like it is my solution, right? So we're going to fill this water bottle up, just like that. Just like that, we have our water bottle filled. And this, we're going to pretend it's the solution, right? So now what you're going to do, obviously, you have your solution here. You add your little bit of soap to this, right? Just soap right over there by the sink, So we've got this, right? And really, I'd fill this more high, right? Uh, but I'm lazy, and this is a little introductory, and I don't want to spill on the floor since I'm not holding this over the sink, so I don't want to fill it up that high. Now, what you do at this point is you take, and I gotta keep this computer from shutting off on me by wiggling the mouse around. That you take the leaf pellets, right? And you're gonna put all 10 of them in here, and it's really gonna be right up here, right? So now what you're gonna do is obviously you want to get as much of the air out already as possible. So you're going to put it up here. And you're going to push down on the water bottle, right? Until it gets right to the top. A little bit going to squeeze out. You don't want to let the leaves go out. And you're going to put the cap on, right? Now we have our water bottle with the leaves inside, right? And they're not floating at this point, right? Because they've still got oxygen. So we need to pull that out of them. So what I like to do is flip it upside down. And I've used up all my leaves already, but the leaves will be still floating at the top. You're going to put your thumb here. You're going to bend the water bottle a little bit, right? Leaves are going to be trapped floating at the top. This is going to be stuck down here. I'm not going to do this now. I can do this over the sink in a second and show you. But you take this water bottle, right? And you're going to untwist it slowly. You're not going to take the water bottle cap entirely off, right? This is going to get rid of a lot of the air and stuff that's still left in there and a lot of the gases. And then you're also going to be able to, shrink this down to size. So let's say we did that. Little cord has little length, so I'm just going to do this right over here, you'd squeeze it, you'd let out some of this oxygen, and we'd have this, this wonderful little water bottle. And as you pull it, it's going to increase the suction, right? And there's a little bit of a technique to this. If you grab it on the bottom, if you try and round it out, with a little 3-fingered grip, or 4-fingered if you can do it, you want to really pinch it, and you want to make sure you pull it, but you keep all these sides out at once by kind of pinching. Imagine like you're pinching and it comes out. So like I'm pinching this, but I'm trying to keep these little 4 extensions that kind of make like an X. I want to keep them out so that I get as much as I can. And then once I've done that, flip it up, get them here, bend it again. You can take this, and then you can let a little more out, right? You can either do that. If you don't want to squeeze it like this, it's a little easier, I found. You kind of squish it down. It's here, and you kind of squish it down, right? You let a little more water out. Now that it's like this, we can extend it even more and flatten it out and keep increasing the suction, right? Now, obviously, this may take a couple times. Um, I found it's not as effective as a syringe. It is plastic. So this experiment took me about 4 hours to do. So if I was giving this replication, I'd probably only give it a 3 or 4 out of 10, right? It took me about 15 bottles, not bottles, but refills with this, before I could get it 4 bottles that were all good with all 10 that were, fairly. I got in one of them, I got only 2 of the leaves remained floating by the time I had finished it, and the highest amount of, you know, leaf pieces that were floating in another was 4 leaves, right? But, that's not too bad in the grand scheme of things. Most of them were, between that and 3. Um, but as we continue, obviously, we're going to run out of water maybe because it takes a lot more than 5 squirts of this. So you take your bucket of solution, right? Um, and let's say, I don't have the bucket of solution. I do have a regular cereal bowl filled with water, right? That's just filled nothing but water. We're gonna pretend that I've done this a whole bunch of times since I don't have that much time to keep doing this. I'm gonna dump this out. So it's like right here, right? It's like real empty, right? We're gonna pretend, and obviously you wouldn't want to let it get that. But, we're gonna squish this down. You know, squish it down real low. You saw it. We're gonna pretend that's what we have. You know, let's say we're running out of water. You take your bowl of the solution. As long as you keep this under the water, you have to have a bowl that's deep enough. So for me, it's a Lowe's bucket. That's what I used, right? You stick this under the water, and do this. So by doing that, as long as we keep it here, we can increase the water so that we can do this process again. And you wouldn't want to let it get that full, right? I found that kind of was counterproductive. Because you obviously want it to be able to float effectively. So this is like probably honestly about here is the lowest I would possibly let it get, and I didn't let it get that low. But you continue that right until you get most of the leaves to sink down to the bottom. Right now, this took me a while. Okay, like I said, this experiment took me 4 hours. It's supposed to only take 20 minutes of preparation and 6 of that. But I don't know. I'm more sciencey. All these ancient scientists, like the guy who made fertilizer. I forget who he was, but like in the 19 teens, I forgot who he was. Some German guy. You know, they make their own equipment. Some extra credit. I'm a scientist. Obviously, clearly dedicated to this class, making my own equipment right here. But and then we get 4 of these, and we take a happy lamp, right? That's what I used. As that. Um, happy lamp here, right? 2 bottles in front of it. Those are your light ones. 2 just behind it, and a kitchen towel over them. That's your other 2 dark ones. Now, something to note: when it does take you that long, obviously I've got some pretty bright LED lights up here. That's that's part of what I'm accounting for. Maybe that's why not all of them floated, because you know I don't know. I thought LEDs took less power. They're supposed to make less light, but they are kind of bright, so I assume they'd probably give off a decent amount of light that would cause some photosynthesis that, would create oxygen, causing the spinach leaves to rise up in the solution, right? So that's pretty much how I did this class. Um, like I said, it took me like 15 tries. Um, only 4 of the bottles were fairly successful in getting most of the leaves to sink. Um, Probably do a series on this, like how to do chemistry F105 when your lab kit still isn't here. I know it's like a running joke at this point. Honestly, it's kind of depressing. But, we have that. As for next, lab, something that I did notice when I was doing this is, uh, maybe it's because it takes a lot longer than a syringe would take, but you can clearly notice a difference in the rate of change when it's going. So, like, say you start with this one, right? Like, pretty much if you tip it and all the leads are up here, right? Before you squeezed out anything at once, when it's pretty much just, standard volume of water, no pressure on it, it's just a full bottle of water, and you turn it back up, it takes maybe a second, maybe two, for it to go up. Maybe after five, it's taking like maybe 3 or 4 seconds, and I only used a normal little. I'm not wearing it right now because I just got out of the shower. Um, I'm just wearing a wristwatch. It counts seconds. It doesn't have tons of milliseconds, so I don't have that. Um, it was about 3 or 4 seconds, and after about 10 seconds was out, it took it about 6 seconds for it to rise up. So maybe for next week you could change rate of change, and obviously you can just measure the water bottle and it's a consistent length, so you always have that. Um, but that could be something that you could do for next week. Something easy. I mean, everybody's got access to 4 water bottles and probably a Lowe's bucket. Um, and a lot more baking soda than it's used. I just thought you might want to know exactly how the specifics of how this lovely experiment worked without a syringe, you know, the wonders of the malleability, elasticity of a water bottle. Physics. It's cool. Um, I hope you have a wonderful day, and I guess I will see you guys all in our discussion and in our lab next week. Do have a good day. I know I will, and goodbye. Thank you.